This is chapter 1.2, solving multi-step equations. Okay, the last one was simpler equations. These ones just have more than a couple of steps. And so I thought I'd throw in these pictures of steps. I thought they were kind of cool. Can you imagine having these steps in your house? This one doesn't have any railing. That's totally against code, by the way. And these are made out of old suitcases. So anyway, I just thought that was really cool. All right, this is a pretty short lesson. So, hey, to solve a multi-step equation, simplify each side of the equation if necessary. So we've got our equal sign in the middle, and if you can simplify one side and simplify the other side first before you start, adding and subtracting from both sides, do that. So simplify both sides, then use inverse operations to isolate the variable. So for example, we want to solve this equation. So in order to get x by itself, well, first of all, I don't have anything that I can simplify on either side of the equation. Okay, so it's as simplified as it's going to be. But now to get x by itself, I'm going to get a new dry erase marker. That's what I'm going to do. I now know that one doesn't work. Okay, I'm going to add 13 to both sides. So I get 2.5x equals 15. And I did that by the addition property of equality, which, it gets to the point where you don't really need to be thinking about that anymore. But that's the reason that you can do that. And then I have a multiplication problem, so I use the division property of equality. And I get x equals 6. And then it says to check my solution. Well, if it asks you to check the solution, that just means they want you to plug it back into the original equation. And I like to put a little question mark over the equals just in case I am not sure I got it right. But this is 15, and 15 minus 13 is 2. So I got it right. X is 6. Okay. So here is another example. Okay. And we want to combine like terms. Now this is a situation where we need to simplify on, one of the sides first. So on this side I just have negative 12. But over here, I have 9x minus 6x, and I can simplify that. That's 3x plus 15. Now I subtract 15 from both sides, and I get negative 27 equals 3x. And now, since this is being multiplied, I divide, and I get x equals negative 9. I'm not going to check, because I don't want to use up the time. But that is how we do that one. Okay. So I want you to try these. So go ahead and pause and, sorry, my stopwatch is looking weird. Go ahead and pause and we'll come back and do these. All right, so here I have both sides are already simplified. And you know what also sometimes helps is if it helps you to draw a line at your equals so that you keep track of, which side is which. But I'm going to subtract 3 from both sides, and I get negative 2n equals 6. Then I divide both sides by negative 2, and I get n equals negative 3. So hopefully that's what you got there. All right, here I'm going to get c by itself by first of all adding 11 to both sides. And that gives me a negative 10 equals 1/2 c. All right, and in order to get rid of this 1/2, I need to multiply both sides by 2. I multiply what's in the denominator. So if I multiply both sides by 2, I get negative 20. So c equals negative 20. All right, and then this last one, I can simplify on one side first. So I have negative 2x minus 10x gives me negative 12x plus 12 equals 18. Now I'm going to subtract 12 from both sides, and I get negative 12x equals 6, and then I divide both sides by negative 12. That cancels out my negative 12, and I get x equals negative 6/12. And if I simplify that, I get x equals negative 1/2. So I hope that's what you got. I'm going to end the video here, and we'll pick up in the next video.